First and foremost, I'd like to say a great initiative that you run, Amit. I've recently been reading a lot of articles that get published on your blog to make sure my knowledge is up to date. So well done on what you do. Keep it going and keep giving back to the community in what you do. So well done on your initiative. For those who don't know me, I'm Mitesh Mistry. I'm a Salesforce CTA. I've been doing Salesforce now for about 13, 14 years. My role mostly recently has been as an enterprise architect, but I grew my career from 14 years ago as a Salesforce developer, doing back then what was Apex and Visualforce. And I've slowly grown my roles into more design, architecture, team management, getting to the point of then looking at architecture, not just from a Salesforce point of view, but how it fits into a wider enterprise as well. In my current role, I'm the CTO at VRP Consulting, and I'm heading up the region for APAC and helping VRP Consulting grow in this market. Some of you guys may know, I also run a CTA Academy called Technocraft Cloud Services CTA Academy, which I'll say a few details on at the end of this presentation as well. So today is about integration, and what I've done today is I've taken one of the assessments which candidates in my academy run. I put a solution together for that to give you a flavor of two things. Firstly, what are common integration scenarios that you might face in the client workplace? And what kind of approaches you should think about when you go about solving them. Now, obviously, each problem may have varying solutions. I'm not going to stipulate this is the be all end all, but this is one approach to solving certain problems as and when they come up in our enterprise. So before I move on, I firstly want to speak about the Salesforce integration wheel. And this runs through what are the typical integration options that Salesforce presents you with when considering Salesforce as one of the systems in a landscape. I'll then walk through 6 integration scenarios that I've seen commonly come up and how you can approach solving them. And finally, I'll say a few words about the CTA Academy, which I run. So let's start here. When we think about integration, I normally think of it in 3 perspectives. So one is UI level integration, one is process level integration, and one is data level integration. Let me speak first about UI integration. So there's a few ways in which this can be done. The most common or typical approach here is having a Lightning Web component and an Apex callout to a third-party service as part of like a UI-based integration. We also have something new called the JavaScript Fetch API. I would suggest this is used with caution. However, if you're going to be making callouts to a publicly available service, which doesn't require any complex authentication, this is something which you can look to use. And then obviously another form of mashup pattern, which forms part of UI integration, is the Canvas SDK as well, which allows you to surface an external application, which is JavaScript compatible inside of Salesforce. The other form of integration now is process integration, where we have the following options. So you have platform events, which can be used as a notification means, let's say, to an external system. We have the Salesforce REST API, the Salesforce SOAP API, which allow for inbound integrations into the Salesforce platform. Recently, a couple of years ago, Salesforce announced enhanced external services. So if you're working with a third-party system and they're able to issue an integration spec in open API format, you can fire up integrations using Salesforce flows and external services. We can also host custom SOAP and custom REST services inside of Salesforce. So this is typically used when you have some form of processing required when a message is passed into Salesforce. It's typically when you look to use these two. For other patterns, we have a trigger plus an Apex callout. So this is something where you might want automation to fire an integration as well. And then we also have Apex email services that fit into this process integration bucket as well. Now, the final area is data integration. So this is when you're looking to either synchronize a volume of data across systems, or you're looking to be able to visualize a set of data in the Salesforce platform. So what are your options? We have Salesforce Connect, which can be used to surface data from external system, but not move it, but show it in Salesforce. We have Change Data Capture, which allows for data updates in Salesforce to feed through to a third-party system. And then for a volume-based data transfer, we have the Bulk API 2.0, which allows for a volume of data to be synchronized between Salesforce and external system, either inbound or outbound. This is typically what I think about when we're solving client problems and looking at what option we'd like to choose. This is kind of my bucket list of options, and we look at it from there when we move forward. So today, we're going to be covering 6 scenarios, which are the following. So the first one is going to be an example of synchronizing accounts from Salesforce to SAP. Second one will be around credit card payments being made via an API. A third one will be around a passport check, which can take a few days to occur by a background service. Scenario 4 will go through a more commonly occurring scenario these days where you have fitness trackers or fitness devices, loads of them, which need to communicate into the platform. Scenario 5 will speak about how do we pull a certain volume of data out of the Salesforce platform. And the last one, which has been a common theme in recent review boards, I would say, this certainly wasn't mine, is if you need to be able to push images into Salesforce, what are your kind of options for doing so? It's something which is worth considering too as well. So let's dive into scenario 1. Let me just minimize my video so I can see this. Cool. So I'll read this out. A customer would like to synchronize their accounts with SAP. So when a new account record is being created or updated in Salesforce, they would like the account record to be created or updated in SAP. Let's assume in this scenario that we do have an existing ESP in place. The generated customer number in SAP, so once the customer is created in SAP, SAP is going to make a customer number. We want that to be written back to the Salesforce platform. So let's now talk about how we'd actually go about doing this. So in my head, I normally think about it this way. So you have Salesforce, you have a user who's performed an update on the account, they finished filling up the fields. Once the key fields have been filled up, we can fire a record triggered flow, a record save triggered flow, which can be on create, let's say. That can then go off generated platform event. And the platform event would act as a notifier. So what would it contain? Typically, you'd have things like the Salesforce account ID, whether the operation was a create or an update, is the kind of information you want to be passing through into your ESP layer. And the ESP, suppose it here in this case, as an example, this MuleSoft, you can read these platform events that are being added to the event bus. It can then make a call back into Salesforce to get details about the account. Now, I'm going to say a few words here. We always have 2 options. You can always have the platform event be heavy and have it contain all the fields which an ESP might need to save yourself a call back into Salesforce to get the account details. I feel that having a notification-based approach is slightly cleaner because if let's say the Salesforce schema was to change, it requires less changes like the middleware layer to get this working. So I've normally gone down this route when I've looked at integrations. So we make call into Salesforce, we pull the account details down, and that could be via a REST-based call into the Salesforce platform. Our ESP would then aim to create a new account in SAP, which would then come back with a customer ID or a customer number and a status. And the final step in this journey is ESP then needs to update the account record in Salesforce to say, this is the SAP customer ID. The integration sync status, let's say, was successful. And it just makes sure that the end-to-end flow has been fully completed. So this is kind of what I think about when I look at a record update scenario between Salesforce and a third-party system managed by a middleware. So what's the pattern being used here? It's a classic example of remote process invocation, fire and forget. And what are the steps taking place? So as I mentioned, we save the record, a record trigger flow is fired, a platform event would contain an account ID, a timestamp, and the operation was a create, update, delete, and this is published to the event bus. ESP, as we said, dequeues the event of the event bus and reads the details. It makes a REST API call to Salesforce to get further details about the account. ESP then goes to SAP, creates the account, we get that customer number, and the last step is we're making a call back into Salesforce, updating the account. And I believe that these fields are quite important to maintain then on the source record. So on the account in Salesforce, you can maintain a sync status dropdown, which could be either success, pending, or failure. In this case, you're setting it to success. Your SAP customer number is being written back into Salesforce, so we have that number present. And you're clearing out any sync error field which may have been present from the past to make sure that's in place. So obviously, that's a positive flow. Sometimes errors do occur, and we do need to make sure we have a good handling mechanism in place for error handling. Something I've seen done before on a project is this kind of error handling approach, where Let's say during our steps of writing data into SAP, we had a failure. So if SAP said I could not create this account. We can do two things at this point. So firstly, we should update the account and say the sync status is not successful or failed. And the sync error can be written back to the account record as well. This is important because the user at least can then see on the account what actual error occurred. At this point, we can then trigger a flow to fire in Salesforce, which can generate firstly a chatter notification so the user knows I need to go and look at this record because something isn't right. We can send an email to IT support if they're going to be looking at these requests. And lastly, we can maintain an error log table, which would contain an error ID, a Salesforce record ID that was in question. So that would be the account ID, the Salesforce object name, so whether it's account, contact, opportunity, the error code, if there is such a thing, passed back from our middleware or SAP system, and also the error description as well. So this ensures that we have a permanent log and the chance to report on as well how many errors are occurring via our integration. Now, when you start introducing these form of logging objects, it's also key to remember that you have to have batch processes in place to periodically clear them out too. So I would recommend, depending on the volume that are being generated, maybe at the end of every month, closed error log records or expired ones can then be removed from the system altogether, or they may be archived if there's some further reporting required. Cool. Okay, I'll move on to the next scenario. So this one is slightly different. So imagine we have an e-commerce application built on the Experience Cloud. In this case, Salesforce requires users to make a payment on an online portal. So the e-commerce platform, it uses an online payment gateway called SecurePay. So how does SecurePay work? Well, SecurePay exposes an API to allow for credit card payments to be done. And the question here is, how would you build an integration for this use case? So we've got an API that we can call out to. It's going to do the payment for us. How do we securely communicate with it? And how do we use it as part of an integration flow? And I've said here again, assume we have an ESB in place. So let's have a look at how to make this work. So in this typical example, it's actually quite straightforward. We would look to implement our own Lightning Web component, which would allow a user to enter their credit card details, their CVV, expiry date, etc. The typical credit card details we need to provide. That will then leverage the Apex controller that we write to make a call out via MuleSoft into a third-party secure payment system. So the flow works as follows. We have LWC invoking an Apex method, which is going to make a call out, control the user's not waiting in the sense that the component won't hang because controls return back to the page. Your Apex controller gets the request, makes a synchronous call out via MuleSoft to the secure payment API and awaits the response. And when MuleSoft gets a response from the secure payment system, it then provides a response back to the calling app server, which then renders the response back to the Lightning Web component on the page. It's a typical example of a request reply integration pattern. Now, one thing I did want to mention here. So I published this recently as well on LinkedIn because it's something which I also understood that has changed. Transactions in Salesforce that take longer than 5 seconds to complete are normally classified as long-running transactions. And based on Salesforce's limits, you can have a maximum of 10 long-running transactions at any point in time. However, having said that, since winter 20, callouts are excluded from the long-running request limit. So therefore, in previous times, I would have suggested for this kind of architecture, we leverage the Apex continuation framework. But since callouts no longer count towards a long-running request limit, continuation framework is no longer required. So something to keep in mind when you're building new request reply integrations. What I'll say here for error handling is that we're assuming here that the secure payment system is going to return back an error, some error details, which can then pass through via MuleSoft and be rendered back to the user on the LWC as well. So it's more for real-time error handling flow in this case. What we can also do is if these things are occurring frequently, we can actually, when we get the error response, we can create a record in an error log table, as I presented earlier as well. And that can make sure that we're also logging any of these real-time errors as and when they occur. So the next piece to talk about for this scenario is security. So how should we secure these form of callouts? So I'd imagine most of you guys are probably familiar with name credentials and how to use them. And this is probably the best example where we should use name credentials to capture our integration credentials. So in here, you're going to specify firstly, the callout endpoint that we're using, and also specify authentication parameters. We can then reference the name credential in the Apex class, which saves us having to hard code or expose our security credentials in the Apex code. You can also have name credentials having different values per environment, which can then help you with integration testing or performance testing or any other sandboxes, which might point to your configuration but require different URI or different endpoint to be configured there. As part of name credentials now, Salesforce recently expanded this out to introduce external credentials. So you can specify here the protocol being used for authentication, and you can also assign permission sets to the external credential, which basically is allowing you to control who is going to be allowed to use this framework to be able to make callouts to this external system. So the thing that you need then, if you're going to be using external credentials, is you must have a permission set assigned to your user, which will allow you to make a call out as external service. And what you can also do is per user, if different users, let's say in a third-party system, have got different permissions or different access rights, you can use custom headers to include user details on the outbound call too, which can then help streamline the response that comes back from that third-party service. So as you can see, this whole call-out framework is much more flexible today than it was before. And there's a lot more things you can specify using point-and-click configuration than having to write it into your code. So there's a lot more flexibility there today than was there before. Cool. Let me move on to the third call-out framework. So the third scenario is here. We have an application process for passports, and as part of this, we have to do a background check. So background check is a background checking service that takes 2 to 3 days to perform verification and will provide a response back to the calling service. So you can imagine that when you're invoking this kind of background check, it's not instant. It might give you a kind of quick confirmation, but it takes 2 to 3 days for them to actually do their checks and come back with a response. They expose a REST API, which allows for a calling system to invoke the background checking service. As part of this, an image file containing a photo must also be sent via the REST API. When a user completes an application in Salesforce, the background check must be automatically invoked. And once the background check is done and complete, the Salesforce application record must be updated with the results. So please advise on how you would look to build out this specific integration. Now, this is a classic example of what in CTA terminology we call a long-running transaction. And I'm going to walk through how this flow would actually run. So firstly, we'd want to be uploading a file in Salesforce. In this example, I'm saying we're going to be using Salesforce files. Once our application and the details etc. we need are filled out, we update the respective record in Salesforce, and that will then fire off a record trigger flow, which, as per an earlier pattern which we presented, we generate a platform event, which would basically notify our ESP that it needs to make a call into Salesforce to get details about this application. So 2 things are going to happen here. Firstly, it's going to go off and get the customer details and also get the file IDs, which it requires to get from Salesforce. And the second call it's going to make is use the file. It's going to use the Connect API to be able to get the file content data from Salesforce as well. So this at this point, it's now got ESP's got your application details and also your file details too. At that point, we make a call to the background check service, and we're assuming here that when you send a request out, you get an instant response in terms of a receipt to say, yep, I've received these details. Once that's done, we then create a log in our middleware, which is basically a notification to say in 2 or 3 days time, this is like an open job, and we may get a response come back for the request that was sent out. So this may differ per middle. I'm not going to say this specific to MuleSoft, but this may differ per integration vendor. But the principle is that your middleware is not waiting. However, it knows that fine, for this particular outbound request that was made, our response is being awaited for to come back. So at step 7 here, the background check is done, and the outcome is sent via a remote call-in to our middleware layer. It will then look at the log record to see, okay, so what was the calling application from Salesforce which submitted this request? And that fires off step 8, where it'll then update the Salesforce application record to say the background check is complete and what was the outcome of that particular check. So this is a classic example in CCA terms that we call a long-running transaction, because it's taking the transaction itself end to end is taking 2 to 3 days to complete. From a pattern point of view, again, try and forget long-run transaction. I think the important thing to note here is we're relying on the ability of the middleware to log details of the fact that a transaction was made, and we are awaiting for a confirmatory response to come back from our third-party system over here. Cool. And how do we handle errors in this case? So there's actually two things that can happen. Firstly, when we make the first call, we may get an error response come back. When a check has been done and complete, we may get an error response come back. And then lastly, we may get a complete timeout. So the timeout scenario could be something where a call was made, it's been 5 days, and we maybe have that kind of timeout in place. And you say, right, after 5 days, if the Salesforce record has not been updated, we need to consider that this is being timed out. So something which you need to keep in mind. Now, what are the approaches for that? I mean, you can always have an Apex batch process that runs, or you can have a scheduled flow that runs, which basically updates the record if the situation or the application status has not changed after a certain number of days. Okay, let's move to scenario 4. So this is a classic volume scenario where we have, let's say, multiple fitness devices, which are tied to smartwatches, which send real-time updates on a person's activity every few seconds. So imagine this, where you're wearing a smartwatch, it uses your your mobile phone's application for that particular device to constantly be sending updates into a platform, let's say, pretty frequently. So when a user will say to use Salesforce, they should be able to see their updated activity details. How do you build this integration? So some things to keep in mind is, would you have the devices send API calls directly into Salesforce? Would you consider building some kind of backend service off platform? What's your thinking behind this? So here's what I would look to do in this kind of scenario. Again, Heroku has its benefits. It doesn't have to be Heroku. You can look to leverage AWS, but I think Heroku, with a couple of license benefits, can actually help this use case quite nicely. So in this scenario, we have your fitness tracker. It's updated something in the connected app that it has on the smartphone. So the smartphone knows this particular thing is taking place. The smartphone will then send a notification into a Heroku endpoint that we configure. Why use Heroku here? It's important because we've got literally millions of devices across the world sending information in. We'd easily lower inbound API Salesforce limits. So by having something like Heroku, which you can scale up and down based on currency load, we can then build an API endpoint in Heroku for this specific use case. We would then look to leverage Heroku Connect. And let me speak about how this would be done. So let's say we are having some form of tracking where if a user's heart rate has slowed down or stopped, we want to make sure that we can notify them via chatter, let's say, from Salesforce. So this is a classic case of where we can use something called an IoT orchestration, and I'll speak about how we can fire it. So if in Heroku, you were to create a platform event, and let's call it a health notification, for example, when you fire the platform event, because you're using Heroku and Heroku Connect, those platform events don't count towards any inbound API limits in the Salesforce platform. They're actually free. So it's something really important to keep in mind for this. That can then fire off an IoT orchestration, which can then, for example, kick off a chat notification, send an email, inform the user. We can look to build automations from there that can actually notify the user or notify health authorities of a certain situation occurring. So it's quite powerful how this particular flow can work end to end. And if a user wants to be able to view their data, so if they want to view their activity records, we have those stored inside of Heroku, and we can use Salesforce Connect to then be able to view that data in the Salesforce platform. So this saves us moving that data across into Salesforce too. And the whole goal or the target end state, as I mentioned, is we want to make sure that we're not blowing Salesforce API limits, and we're also not transferring a mass volume of data into the Salesforce platform as well. So this kind of architecture suits this use case really nicely as a result. Okay, we've got two more scenarios which we'll run through. Scenario 5. So in this case, we want to synchronize a volume of fitting account records from Salesforce nightly to the finance system. Now, assume when we say volume, we may be talking 100K plus. So it's a substantial number at this stage. How would you do this? So assume that we have an ETL tool in place to help us. What APIs would you use in Salesforce to extract the data? and send to the finance system. How many records would you be able to pull down at a single time from Salesforce? Are we constrained by a so-called limit of 50K, or can we get beyond that? This is an important point to look at for this one. Let's have a look. In this case, I'd look to leverage an architecture like this, where we have an ETL platform in place. We use the Salesforce bulk API 2.0 to be able to get all their changed records or changed or created records since the job last ran. Inside of our ETL platform, we maintain a job last run date. This is basically tracking when was the last time our integration job ran. And we're looking for all the records that are modified since the job last ran. And ultimately, what we're then doing is we're then going to be writing and updating our records in the finance system from the ETL tool. So let's say a few words about how the bulk API works in this case. Firstly, the bulk API, it's REST-based and works in an asynchronous fashion. When you make a query, traditionally bulk API tries to find the best way of dividing your query results into chunks and then sending back each chunk. So I'll speak in a second about if you don't apply your own numbers, how does Salesforce approach PK chunking and what it is? I'll speak about that shortly. Our goal is here to avoid timeouts and give enough time to process the chunks before the next chunk arrives. And we can do custom retrieval chunking as well, which I'll speak about. So how does bulk API work? Well, firstly, we have to make a bulk API request with a specific query string. And Salesforce provides you back a response along with the job ID. Salesforce starts retrieving and fetching the data in the backend. And then what you can do is then you can make a request back to Salesforce using a third-party service or your middleware, which will include the job ID and also the number of records you're trying to pull down. You'll then get the records back in the response, and you'll also get something called the Salesforce locator parameter. So in this case, if you're looking to query or pull down a certain number of records, the Salesforce locator basically tells you inside of the records that you're pulling down overall where you're at, so that you can use this to then make the next call in to get the next chunk of data. So this ensures that you're getting records in a sequence that they've been requested in. Let me just show that and what it looks like. So in the response that comes back in the bulk API, when you're actually trying to get your data, you'll be passed back, as you can see here, the Salesforce locator, which has got this coded ID that you see. And if the Salesforce locator itself is not null, it means that there's more records present. So your whatever middleware you use, or if you're custom building your integration layer, if you see the Salesforce locator populated, it means you need to, again, keep making calls in to get the next chunk of 5,000 records that you're pulling down in your next request call. So this example itself is an example of batch data sync integration pattern leveraging bulk API 2.0. The bulk API 2.0, when you're doing the query like we are, it allows you to asynchronously process those local queries. The bulk API itself can determine the best way to divide up your query job into smaller chunks to avoid failures and timeouts. What you're ultimately trying to do is find a fine line between how many records to pull down in a batch versus how long it takes you to get them to avoid timeouts occurring. It also automatically handles retries. So if it'll try 15 times, and if you receive a message API retry more than 15 times, you might want to look to restructure how you're querying your data or apply a certain filter as well. The response body that comes back to the query job is compressed, and CSV is a supported response type from the bulk API calls, which you make. I just want to say a few words about PK chunking and how that works. So PK chunking splits the query based on the Salesforce record ID. Each chunk which you have is processed as a separate batch. So the chunk size default is 100,000 records. You can obviously make it less or more, but the maximum chunk size you can set is 250K records in Salesforce. When is it recommended? So if you're querying tables which have more than 10 million records, or if you're seeing a bulk query consistently time out, this is the right kind of time at which you will want to leverage PK chunking or some other form of chunking framework to get your data down. You then leverage your job ID and batch ID to get details of a specific batch and pull the data down. And also, as I mentioned, how effective the PK chunking is depends on how big your query is, and also what is the data likely trying to pull down as well from Salesforce. So a few things to keep in mind when you're using bulk API 2.0. So the following items are not supported as part of a SOAP query. So these clauses are for group by, limit, order by, offset type of are not supported. Don't use order by or limits as they'll disable PK chunking for the query. And obviously with PK chunking off, the query itself will take longer to run. Aggregate functions such as count are not supported. Date functions and group by clauses are not supported. If you're using compound address fields or compound geolocation fields, you need to physically request the individual fields you want and not try to pull down the compound structure. And also, parent-to-child relationship queries are not supported too, but child-to-parent are supported. If you're trying to fetch something, let's say from opportunity to account, that's fine. But if you're trying to do something from account and get me child opportunities, that side is not supported in that way down. Cool. And final scenario for today. So in here, we have an estate agent who creates property records in Salesforce. Against each property, we have a need to upload property images. So in this example, we're assuming that for each property, we have 20 pictures that we need to upload. Each image itself might be 10 MB in size because they've been taken as high resolution. Inside of our platform, we have 500,000 properties that need to be migrated onto Salesforce. What is your solution for storing the images and making sure they're accessible against the record too? So the very first thing to do in this is a common one that comes up on review boards. So I would say the first thing to look at is what are our numbers? So we understood we had 500,000 properties. Each property goes with 20 images, and each image might be 10 MB in size. So that tells us right now that we have a requirement for 97,656 GB in Salesforce. Now, anybody looking at that number will know that number is big. And unless you are purchasing a really hefty number of licenses, you're probably not going to have that kind of storage space in your Salesforce org. So what are your options? So one option is to leverage Salesforce Files Connect. And if you're having in your enterprise SharePoint, Box, or Drive, could be one means of storing this image data. And then having it surfaced in Salesforce through Salesforce Files Connect. That's one particular option. Something which I've seen pretty commonly used in this use case is having a custom solution that you build out using Lightning Web Components and having your files stored externally in something like either Azure Blob or Amazon S3. And we can then, you'd ultimately have to build two LWC components here, one to manage the file upload, and then one to manage the ability to view files against the record as well. What you then would also look to build is you'd maintain a custom object against the records where files are being stored, which can basically contain a link to the file and the name of the file. And this is a really common solution I've seen used where you're using external repository to store your file content. And the last option you have is leveraging an app exchange-based solution. So something which I've heard about in the past is S-Drive. You can use something like this, which would provide you an app exchange-based solution with pre-built configurations and security mechanisms in place to be able to store your files externally and then be able to view and interact with those in the Salesforce platform as well. Obviously, if you're introducing a third-party solution, such as App Exchange, you'd have to consider the license implications of using that as well. Cool, and I'll just touch upon two more things before I finish off and open for questions. So 3 things, simply put, when it comes to integrations, I would say is number one, first and foremost, don't overcomplicate it, keep it simple. So think about what the practical and pragmatic use case is, and keep your integration build and integration delivery simple in what you do. Keep it practical. So ultimately, you want to build a solution that works, that is performant. It doesn't try to do too much. And lastly, you want to build something which can scale. So ultimately, it's very easy to build an integration for a low volume use case and say, fine, 10 records passing through every hour, that's fine. But when you start having concurrency, when you start having load, it becomes a different ballgame, where it starts to become a dependency on other systems being as performant as your calling system or initial entry system is. So you want to be sure that whatever framework you design, it can scale up to the enterprise volume use cases as well. Those are 3 things to keep in mind when building out integrations. Now, the last thing I wanted to mention, I just want to say a few words about the CTA Academy, which I run, give you guys some information. And if anyone's interested in having a further discussion about this later, we can take